Here, maybe that'll make it go faster. The first problem that we said with this thing is that this function is standing as a class all by itself. It really belongs inside hockey players because its entire job in life ever is just going to be to do something between two hockey players. And so it shouldn't be standing out on its own. We'd like to put it inside hockey player. So let's go do that. I'm going to cut out everything that's here in the entire class, and I'm going to go into the hockey player class, and I'm going to go right down near the bottom, and I'm going to paste that class in at the bottom of this other class, minus that end brace, which is the ending brace for the hockey player class. So I basically embedded an entire class within another class, the definition. Okay? And that gives, there's the braces as belonging to, this is now a part of this other class. Okay? And just to be sure, I'm going to close up hockey player class, and I'm going to stop listening to that guy. And just to be really clear, I'm going to call this name, this thing, we'll call it first name or last name. So I just did that to rename the class to show you I'm no longer using that other one at all. Okay, it's gone. Okay, so there's that class now embedded inside here. So now I'm going to go back to my driver, and I'm going to use the other one. So in my driver class, down at the bottom, I had hockey player alphabetizer, and now I have to remember the name I used, which I'll copy and paste out of here. So we'll just change this name to the one that's inside the class. We'll change that one to the one that's inside the class. And notice that it doesn't recognize it at this point because it doesn't know where to get that thing. And the reason it doesn't know where to get it is because I embedded it inside hockey player. So I'm now going to refer to this as hockey player dot last name comparison. Got that right. Likes that side. Doesn't like that side. Yeah, close enough. It's okay. I'm going to fix it sooner or later. I sort of know why it doesn't like that one, and I'm not going to worry about that error message for a start. Okay, so that's one way of fixing it, which sort of almost works other than a minor detail. Rather than me doing the new here to go out and make this guy myself, I'm going to turn the tables on this thing, and I'm going to force the hockey player class to give me the new guy instead. Okay? So I'm just going to take this thing, I'm going to bury the creation of this hockey player guy inside the class, and I'm going to write a getter that makes one of these things. So inside the hockey player class, I'm going to write public comparator for hockey player Actually, I'll do it this way. Yeah, sure. I'm struggling with some Java isms here, trying to make sure I get them right. And some of the easier ways aren't going to work. Comparator for a hockey player, get comparison. and I'm going to make that one return new last name comparison. And hope that that works. Okay, so notice all that I did was I dragged the new thing inside here that used to be in main, and then I provided a getter that will give that thing back. And so it's making a new one of those objects, just like we did before, only now it's coming from within the class, and I'm sending that thing out to where the driver can see it. So now what I do when I want to actually make the comparison, I don't do the new thing myself. I ask one of the hockey players, in this case we'll ask Daniel, if he will supply me with the guy who's going to do the comparing. And it might almost like that. And let me just change this. In general, this is a comparator, and if I'm lucky, I can do this and be a little less specific. And include my import statement. And I'll get something that looks like that, nicely without errors. Okay? So what this line has become is Daniel knows how to find some third party who will do comparing in a different way than the normal thing for hockey players. So I'll go ask Daniel to give me that guy who can do the comparison. The guy that I'm getting back in general is somebody who can compare hockey player against hockey player, and that thing is saying that he has a compare to or a compare function inside him that will take two hockey players. So I stopped using the specific name for the class that I'm written, and this is the more general idea that someplace inside that thing, the thing that's coming back from that class, if we go and look at it, says implements comparator, meaning I've written that compare function. And the only thing I need to know about this class that I'm getting is that it somehow has that comparison routine inside it, and as long as it has that comparison routine inside it, then the sort will be happy enough, or the min will be happy enough to use it. Okay? So that was just an exercise in saying, let's go hide the thing. Questions about that? Moved it into hockey player, moved the work of who does the hiring into the hockey player class, so he goes and gets the guy and gives him to me rather than me making the guy. Okay, well that's not bad. At least I've buried the thing inside. And just to be a little clearer on that get comparison, that's a little too vague. And so what I'm going to do is I'm going to change the name on this to something like get last name comparison. Or even better yet, maybe we'll call it just by last name. Sounds a little better. Give that thing a try. And so in the driver, see if this makes our life easier. This is Daniel dot by last name. Maybe that's a better name. So I'm trying to give the sense by that thing of what the comparison is to try to make the words better there. So the last name comparison variable has got something that's doing the comparison apparently by last name. Okay, still works. Next problem. This thing, in order to use it, I always have to have a hockey player in my hands so that I can turn to the hockey player and say, hey, I need you to go fetch me the guy who will do this. Now notice it doesn't matter what hockey player, any hockey player will do, they all know how to go make this new guy hire a new guy, right? Because the function is common to them all. But I have to have made a hockey player first in order to do this comparison. Okay? Got to have at least one to speak to. And that's going to annoy me a little bit. I don't really want to have a hockey player that I have to speak to get that function out, to get that guy. So the next change that we're going to make is we're going to go into this class, and this is the one that somehow always messes me up. Let's see if I can do it correctly. We're going to put the word static on there, and we're going to put the word static someplace here if I'm lucky. And we'll see if that makes me happy. So I put the word static on that thing, and now I'm going to go change this word to just hockey player. Okay? So the effect of that static word is to say you no longer need an actual object from this class that's been created by new in order to make use of that function. Okay? If you think about things like, for instance, collections.max, it's the same thing. We didn't have to make a new collection object in order to then turn around and call collection object.max of something. We used the class name .max in order to invoke that function. So it's a way of providing a function, basically, where you don't have to have a thing in order to do it. Okay? And so that will just magically supply the comparison routine for me. Okay? So now it looks a little better because I'm saying, go to hockey player, ask him for some sort of by last name comparison thing, and then we'll use that for collections.min and for collections.sort as an alternate way of doing the sorting. Gets even better. So there's the reason for putting that static word on the front of both of those functions, is it makes them usable with class name dot function name without having to make a new hockey player. Still with me? Not done yet. Notice what happens in the getter for within hockey player. The getter within hockey player uses this class name only long enough to make a new for this thing, and the only association here that needs to be made is that this thing and this thing go together. And it's never going to be anything more than that. And so what's going to happen is if I repeat this pattern and I make a first name comparison idea, then I'm going to have to repeat this code, make a class that says first name comparison, and only use it long enough to plop it into there so that the getter knows how to make one. Okay? And so basically I'm going to have to come up with silly class names here for this thing to hook these two together, when in fact that thing is a good enough description. Hopefully the getter is a good enough description of what I actually want to do. This thing is sort of useless. Okay? So let me eliminate it. I'm going to go here, and I'm going to just sort of basically take the stuff that's in common here, which is all that stuff. So notice last name comparison and a class that says last name comparison. And if I'm almost really good, I can just wipe those things out. And one last little thing I'm going to have to do, which is sort of not obvious, if I get that in the right spot. I think it belongs about there. I get that in the right spot. Think about this for a second. I think it's back here. New comparator. Let me run source format for a second. Sometimes helps to fix it. Nope, it didn't. I'm just looking here to see if I got it right. Missing that, I think. There we go. And now we'll move that down to this line. So a couple little syntaxy things to fix up. And now I may be missing a brace.
Yeah.
Something along that line. And now I'll just run source format to clean it up. Okay? But you saw basically it was eliminating the middle chunk of the names from the thing. And so now what you end up with is this chunk of code where the getter, rather than making a class or rather than having a class name, just does a new comparator and then proceeds to write the function essentially directly. And in case you're wondering why I put this little semicolon in there, the little semicolon is there because it ends the return statement. Okay? And so that's the weirdest part of the lot, is that thing has to be there, otherwise it doesn't function at all. Okay? So we'll save that, and there's basically the final result for the pattern for this thing. Still does exactly the same thing it did before, but in the driver program, I've gotten it down to just ask the hockey player class to give us the object that contains the function we want to use, and pass that object containing the function along to the sort routine. Okay. And inside the class, when you call the getter, it just says, oh, I need to make some sort of new comparison beast, and new comparison beasts always have this function in it to compare two things, in this case hockey players, to each other in order to do their work. Okay? And that's what you'll normally see those things look like. The first version, where I used the class inside, was known as an inner class because it hides inside some other class. And now what I've got here is a class without a name inside another class. And so this is known as an anonymous inner class. Okay? Because it has no class name to describe it. This sort of style of things, of using anonymous inner classes, happens a lot, particularly in GUI code, when you're trying to do things like make action listeners. If you're used to using them, rather than having to give the thing a name and then make a new one to use it, you just basically write the code in line where it belongs, rather than having to separate it out someplace. And so it's sort of an inline way of writing code and eliminating some names that aren't really doing you any good. Okay? So you'll see this a lot more in GUI code than you will in this style of code, but it happens to be handy here, and that's a good place to show it. Okay, well, let's do the test of this thing. Suppose that I wanted to not only compare hockey, or not only sort hockey players by last name, suppose I wanted to sort them by first name and then last name. How would I go about doing that? Make another one of these things. So let's just steal this code that says by last name, and we'll just write it down there. And oh, I guess instead of by last name, it would be by first name. And how would you have to change this thing to do it by first name?
Flip first and last?
Yeah, basically just flip first and last. I don't know if there's an easy way of doing this without really messing it up. First name, change this to first. and then it's last, and this should be by last. Like so. And so let's see, it gets their first names, take the difference of their first names, otherwise use last names and take the difference of their last names. So it's basically just the reverse idea. Okay, plug that one in there. There's my alternate form of comparison, and if I want to go use it, you now go back into the driver and you say, oh, instead of calling the getter for by last name, let's call the getter that gives me the by first name object. And now the driver program has the easy use of the thing. Oh, okay, I just talked to this thing. He's got a function that looks like the name I want to use. Off I go. And you're welcome to have all of the variations, you know, by points, by first name, by goals, by last name, by whatever options you want to put in. Oh, not quite done yet. One other little optimization. How often do you think these guys get called? If I've got 1,000 hockey players and I want to sort them in terms of points, any estimation? How about, let's do worst case, because that's easier. How many things would I, if I've got 1,000 hockey players, how many pairs of things would I have to compare?
999.
Squared. So worst case for doing the pairs of things, if you did it in the absolute worst case way that you possibly could, would be 1,000 times 1,000 comparisons, meaning 1,000 squared calls to compare to, or in this case, compare. Okay, so this is one of these things that because it's called so often, it's better if we can somehow make it run faster. Even a little bit faster in this case is probably going to help. Okay, and so now the trick becomes, one of the things that's slowing it down is that I have to go and call each one of these hockey players and say to them, oh, could you go get me your first name? I have to ask. Remember our special rule?
You don't have to, 'cause it's embedded class.
Now, since this stuff is embedded within the hockey player class, it's supposed to know all about hockey players, and so it can go and grab the values of the variables directly. Okay, and so I'll start out by saying it doesn't have to call get first name, it can just call a dot first name. And this one can be b dot first name instead, and now it's not a function, it's just, oh, let me go grab that hockey player variables directly. Okay, well, if you can do that, then it probably makes more sense to just eliminate these variables altogether and do a dot first name compared to b dot first name. I got that right with a small f because it's the variable. Okay, and the same for this one, I can eliminate that thing and I can change this to a dot last name minus b dot last name. Okay, and so there's the special performance rule. Don't have to go ask anymore. I know all about hockey players because I'm inside the hockey player class. Just let me grab this piece of information off his desk. Let me get that piece of information off his desk. I'll do the comparison and I'll give it back to whoever wanted it. Okay, so that's the better, faster way to write it, and that's the thing that comes from the ability to drag it inside the class. So we get a performance improvement by dragging it inside the class, and we also get the idea that this stuff belongs with the class anyway, so let's put all of the code for this thing together. Okay? So good people who write this class will probably supply some variations on those things for you. What if they don't? Are you stuck? I still have the other one here. If you're stuck and people haven't supplied the sort order that you want for the thing, the old fallback is still there where we started. There's nothing to stop you from saying, oh, whoever wrote hockey player didn't do a good job of writing whatever sort order I need. Let me go write a totally separate class that has a compare in it that can work between two hockey players. And in this case, because it's outside the class, I have to use the getters, so it's a little less efficient than it would be if it were inside the class, but I still have the ability to do whatever I want. So now you got the best of both worlds. If they're written for you, that's great. If they're not written for you, you can write your own. So that one can still stick around and be changed to other things also. So I said there was a bottom line to this when I started. The bottom line of this is that all that you need to do if you want an alternate form of comparison in your class is basically borrow that pattern and do just like we've started to do with compare to. If it's a student, you just change that, all of the words that say hockey player to student, and you use whatever fields you have inside the class as mechanisms for doing the ordering that you want. If it's names, you call strings compare to. If it's integers, you do the subtraction yourself for the different fields to get the difference. And that's all there is to it. And once you've written that pattern, when you want to use it, all that you have to do is, instead of hockey player dot by first name as the thing to go make it or go get it, you're now just going to change that to student dot by GPA or whatever it happens to be as the way of your sorting mechanism. Okay? So there's the two pieces of the pattern that you can finally steal from whether or not you understood the little trick of derivation to get where we needed to go. So now you can sort in any manner that you choose, basically. Okay. So sooner or later I'll make a lab on this for go out and try it yourself, or we'll do another example of it pretty quickly. Questions about that? Very useful little tool. Sort will do most of the work for you. And we can see we're getting a lot of benefit from being able to do this all without too much work. Don't have to sort yourself. Facilities are already available. List is already available. Life is good. Okay, let's do a little quick introduction to something else here. Let's talk about, start a brand new project here, and let's talk about something like a music player. Okay, so music players. Let's go back 10 years. Remember those things that came out before people had phones that just played music? What were they called, like iPods or something like that? They still have one of those? Like iPod type things. You remember before that there were those things, those brown discs that used to shove into computers, and they had music on them before people started stealing stuff.
CD-ROMs?
You still plug them into cars though, don't you? Oh, no, you got Bluetooth things that do that, so those things all went away.
Cassette players?
Okay, so let's talk about, let's just go with iPods maybe, because they're physically easier to think about. So whether it be an iPod or somebody else's music player that's the same sort of thing. If we were to go out and start writing a class for a music player, let's just think about what kinds of things we could ask our music player to do. You get your fresh iPod thingy from the store, and what's the first thing that you're gonna have to do with it?
Put music on, put it in the blender.
Gonna have to put some music on it. And so, some way or another, we're gonna have to write something that says, I wanna add a song to the player. And we'll pretend we have to do it one at a time. If you add a song to a player, what are you gonna provide as information for the player? A song. Do the simplest thing, regardless of the details, it's gonna be some song. Okay? Oh, well, if I said song, the noun, in capital letters, I guess I need to write a song class. So let's go write a song class for our music player. And let's think about what sort of information we'd want to record for a song.
Artist.
Any other information? Okay, so if you think about an iPod one way or another, on the display, if it's a fancy one, you're gonna have the name of the artist, the title of the song. What other information would they normally display? Called playtime, or would you rather call it length? What's the good word for it? Track time, track length? Okay, we'll go with track length. Okay, so you'd have a bunch of information, and all that's basically fairly static information, so I'm just gonna leave it at that. I think I've got enough idea of what it might eventually be. And so now we can go back here. Don't worry about the red marks. We'll make them go away eventually. Okay, so you'd have to write some sort of method in your music player that did that. That'll make that thing happy for a moment. What other, okay, so you got your song on your music player. What's the next thing you might want to do with your music player?
Play that song.
So if you play that song, I'm going to call it a little bit more generic. Play next song. Any arguments for play next song? If it's the iPod type
What the next song is.
thing, simplest version is you can't select, right? You press the forward button or the play button and it just plays the next one. Okay, so not gonna worry too much about that. We'll have to write something that just somehow advances. When you turn it on, isn't playing anything. You press the button, it starts playing whatever's there. Anything else you wanna do?
Like previous song, or just start again.
Play previous song. Sure. Anything else?
Play a random song?
Yeah, we could do play random song eventually.
Search.
No, you can't search because that would involve, I'm just trying to think of the dumb iPods before they actually
Stop.
had keyboards. Stop maybe. What information did they show on the front? What's the other thing that you would
Pause.
normally see on the screen?
Song. Battery size.
The dumb ones didn't have a display screen, but the ones that had a display screen,
What music, like,
Bin rate?
there would be probably a menu that lists out what the songs are that are available, so that you could at least use the pad and scroll down and hit enter to play a different one. So I guess there's gotta be some concept of show me a list of songs. Okay, so what's the simplest way of getting a list of songs out of your iPod?
Having a list that has all the songs?
Well, presumably it's keeping a list inside, so we've just gotta go be able to ask it for things. So if you pick up your iPod, what's the first question that people used to ask about it if you showed your iPod to somebody else? What's the thing that makes mine better than yours? How many songs are on it? Probably, oh look, I've got 3,000 songs on mine, you've only got 5 on yours. So I guess there's some way of saying, tell me how many songs are on your iPod. Anything else that goes with how many songs? If you can find out how many, what's the thing that goes with how many? How about go get me one? Go get me information about the first one. So someplace or other, there's gotta be the converse, which is public song, get song, or song information if you wanna think of it that way, at some particular position. Okay, so those two go together, because if you know how many of them are on the thing and you want to produce a list of them, you can now go through and ask for the number 0, 1, 2, 3, 4, 5 song until you've gone through all of them, and you can somehow provide that information out in some manner. Okay? So, now let's suppose that I turn around and say, well, that's enough. I think that's probably all we need to get this thing working. It's enough functionality in it that hopefully I haven't forgotten anything. Now I want to turn this into a class assignment. Okay? And so I want everybody to basically go write the code for those functions to do the work, now that we've agreed that those are the functions that are required. So this becomes the general assignment for a music player, right? Okay, here's what I'm gonna do with the thing. I'm gonna decide that I'm gonna be lazy and I'm not gonna write any of these things. I'm just going to provide the words to you that you need to use. So I'm gonna put semicolons at the end of these to say I'm pretty much done with them. Get rid of that one. And then to turn it into assignment, I'm going to further say I'm not much interested in writing this by doing that. I think I got it just about almost right. Ooh, I guess obviously I've got 2 of them in there. Who knew? And I'm just going to do that. Oh, look, no syntax errors. Okay, so basically this is a definition. This says for lab 5, there's the stuff you need to write, and there's the information coming in, and there's the thing that's going out. You people all go write this. Okay, so here's what you would do as the next step of writing it. You would say, oh, well, Pfeiffer gave me this idea of a generic music player, but I want to write one for, let's suppose we're doing, well, I don't know, Fred's music player. I'm going to say, I mean, it could be, I want to write the iPod to do this, or I want to write the, whatever those other companies were that made the clones, but I'm going to call it good old Daryl Pod. Okay, so this is my take. I'm building one of these, I'm manufacturing one of these. And now for DarrowPod, I'm going to use my fancy implements word here, music player. And so basically what this is saying is I'm going to meet the standard music player. I'm going to do whatever a standard music player requires. Okay, that's my promise to do all of those functions. The shortcut for that is to go in here and say add unimplemented methods. And now what Eclipse does is it fills in all of the stuff that I'm supposed to write. Okay, and so you've sort of seen this before already, but this is the longer process of it. So the difference between the two is that music player is the generic standard. That's what everybody should be doing. And it's described as an interface to say there's nothing in here other than here's what meets the standard. And then this is me coming along and saying, oh, I can write one of those standard things. This is my name for the thing that's going to do the standard, and I promise to write all of the same methods that the standard requires. And if I do that, presumably there's a set of unit tests that go along with this. And if I meet the standard and run through the unit tests, then I can put the little sticky on the front that says, hey, I speak music player.
Sorry, I missed how you just did that.
When it gives you an error, you just go click and there's an option that says add unimplemented methods. Okay? And notice it basically says, well, to meet the standard, here's the stuff you have to do. And it's broken, but at least all of the code stubs are in there to do something. And now what I can do is I can go, if I want, I can go back and write the unit tests to make my one work like the standard should write. So the thing that's missing here is the unit test at this point. Okay? Now, here's one quick thing I'll say about standards, is that we wrote this standard as a sort of thought experiment. We said, well, if I wanted to do something with music players, I wonder what I would be. In actual fact, standards are usually done the other way. Somebody comes along and they write one thing, somebody makes another product that looks sort of similar, and then we have to sort of look at both of them and go, well, they sort of do the same thing. And if we made them function the same way, then they would be interchangeable. And so people go and they take a look at their prototypes and they go, oh, well, you're doing it that way, you're doing it that way. But in general, here's the things that we have in common. And so you generally extract the standard from a whole bunch of people doing it the same way. Right? And so that's probably the more natural way to come up with it. And then people go and they change their standard to fit, or what they built to fit the standard in reverse. Okay? So the standards are all over the place, right? There's a USB 3.0 standard, right? The standard says if you want to put the USB 3.0 sticker on the front of your machine, then here's what the standard says that you have to do in order to make that happen. Okay? In the old days of when songs came on CDs, believe it or not, there's a standard someplace for manufacturing the CD that says it's going to be exactly this big, it's going to be exactly this thick, it's going to be able to have exactly this much information stored on it, you're going to have to use this type of laser to read it, a very exact description. And that meant that people, once they had the standard, could then go off and make their own CDs, manufacture them, and get the little stamp of approval that says these meet the standard. Okay? So this is going to be a real powerful thing for us to start with. And so you'll see that interface idea used a lot. So we've seen it used with Compare2 already. Compare2 is a standard that says, or comparator is a standard that says there's got to be a Compare2 function inside the class. Right? This is no different. You know, music player is a standard that says there's got to be these 4 or 5 functions inside the class instead of just one. And so it basically defines what you have to write. And with that, we're out of here.